So during indexing, since the input collection and the output is index file, the document has to be converted into index terms. To convert the documents into index terms, we have to apply tokenization, stopper detection, stemming, normalization. Then when we are reaching to this level, we have a vocabulary words. Vocabulary words means distinct words. Words that are appearing only one time. All the different variant words are conflated and they are non-content bearing. So for those words, we have to attach their frequency. That's why we need the term weighting. We are weighting terms or words from different perspectives. For that, we have term frequency, document frequency, collection frequency. Term frequency means it's trying to calculate the frequency of the term or word in a given document. How many times a given word appears in a given document. Term frequency is restricted to identify the number of times a given word appears in a given document. So take one term, see it how many times it appears in one document only. That will give you the term frequency. The other one is document frequency. Document frequency is trying to see how many documents are containing the terms that you are looking for. Given term I or word I, we are trying to see how many documents containing that word I. That is the document frequency. How many documents contain a given word. Then comes is collection frequency. Collection frequency is trying to see the total occurrence of the term within the document collection. That means take from I1 to n number of documents that contain a given document, then sum over the term frequency of that given term in each of the document. If there are 10 documents containing term I, then see that term I in each document and the sum over all. Summation of the term frequency of a document across the document collection will give us collection frequency. Later on, we will see, based on term frequency, document frequency, collection frequency, we try to calculate inverse document frequency and TF-IDF, term frequency times inverse document frequency. We'll see those things when we reach to that point. Now for indexing purpose, we need term frequency, document frequency, collection frequency. Of course, there are index files that doesn't apply term weighting. But this one is a generic architecture. It's good to apply term weighting because later on we need it when we are constructing term by document matrix. Then for each document, to easily identify them, we have to use a document identifier for each document. In the internet world, the URLs are used as a document identifier because a URL assigned for each document is unique. As a result, the search engines are using the URL of every document, which is unique. When you are designing information retrieval system, you have to assign a document identifier for each document that are used for experimentation purpose. So those document identifiers are used for indexing the words that they contain. Once the indexing subsystem is complete, then comes is the searching subsystem. As I said, indexing subsystem is an offline process. There is no connection, there is no interface to the users, but searching works when users are initiating for searching as per their own query that express their information need. So the searching subsystem starts working when users are providing query. Like we do for indexing, again for querying also, we need tokenization, parse query. We have to convert the query into words it contains. Then as we do for indexing, stop word, stemming, normalization should be applied, in addition to term weighting. The term frequency, document frequency, collection frequency should be computed for the query. Then similarity measurement comes. The similarity measurement is responsible for comparing the query with the documents that are indexed using their index terms. When the similarity measurement is working, it is comparing the query terms against the index terms. So to what extent the index terms that comes for each document are similar with the query terms. Like cosine similarity measurement, which is widely used, can help us to calculate the similarity score between a given query in terms of the query terms against the document collection in terms of their index terms. For each document, using its index terms, it is similarity with the query term is calculated. Finally, those similar documents, as per our criteria to say similar, retrieved. Obviously, when we are searching, especially if you are designing a public search engine, if it exists, at least if the query word exists at least in one of the document, that document is relevant. That means if it is registering greater than 0 similarity score, that document becomes relevant. The document is irrelevant if it registers a similarity score of 0. 0 similarity score means the document is irrelevant for the query. If it registers greater than 0 means the document is to some extent relevant for the query. Because when you are measuring the similarity, we are applying partial matching. Partial matching means if there is at least one word in the document, one query word in the document, that document is relevant for the query. As the number of query words available in the document increases, the similarity score between the document and the query also increases. That means the relevance of the document for the query also increases. The document becomes irrelevant when, if that document doesn't contain any of the query terms. That's why it's registering 0 similarity score. If you are applying partial matching for identifying at least a document which contains one of the query words, then you have to apply ranking using best matching. Best matching means rank documents based on their similarity score, such that those documents with the highest similarity score should appear as the beginning of the search result. at the top of the search result, in the first, second, third order, we have to get those documents with the highest similarity score. Highest similarity score means those documents which are registering better similarity score. As the document is containing all the query terms, it is getting a better similarity score. As a result, ranking will try to list out based on the degree of relevance of the document for the query. As the relevance increases, the document will get a chance to be ranked in the first 1, 2, 3, 4 orders as per the similarity score. So those ranked documents are returned for the users. If the users are not satisfied, they can modify their query and search again. So the search engine will accept their query just by applying the query preprocessing tokenization, stop for detection, stemming, normalization, and terminating. Then again, similarity measurements are applied to check is there any document in our index similar with the query. So index and the searching are totally connected. Without indexing, there is no searching. Without searching, there is no indexing. Why? First of all, we are thinking about indexing if there is searching. Then when you are thinking about searching, there should be indexing. Then if there is indexing, we have to design searching. Indexing helps us to organize the terabytes or petabytes of collection that are available in the author's or producer's world. Organizing the document collection is the base for optimizing searching. Indexing will help the R system to consume only less memory space. As a result, both indexing and searching are critical. So now, how can we construct the index file? So the issue is what kind of indexing structure we have to use for organizing index terms, basically. Index terms collected from document collection. There are many indexing structures available, but the most frequently used indexing structure is the inverted file. Why we need indexing? On the one hand, to organize documents systematically obtained from the reader's world, the author's world, or the producer's world. On the other hand, why we need indexing is to speed up searching and accessing the relevant documents and presenting for the users accordingly. So indexing is critical for optimizing the efficiency of the IR system. So accordingly, what kind of index file to use? We have to think, because the index file is containing index terms. One index per row. So index terms are records for the index file. As we use the index file by organizing them using the indexing structure, we are trying to systematically organize our index terms such that searching becomes more easy. Now, since, as we said, before constructing the index file, we are trying to apply the pre-processing techniques or text operation techniques. Even if you ignore the text operations, and if you bring the index terms just after applying tokenization, and if you compare the index file with the original file, since most of the words are the same, we are using end 25% of the time. We are using stop words as frequent as possible. What scholars are saying is, few words are used frequently for writing, but few words are there that are content bearing. What are those frequently used words? And that are also rarely used for describing the content. If you identify those words, the index that we are constructing is minimal. And even there is a law called Heap's law. After conducting experiment on English textual documents, they defined that in a 1 GB text collection, there is only a 5 megabyte vocabulary, means distinct words available. So just by identifying only distinct words, we can compress the total number of words from 1 GB to 5 megabyte. So immediately the memory space requirement also reduced. That's why selecting vocabulary by itself is a compression technique that can help us to minimize the memory space requirement. If in a 1 GB text collection there are only 5 megabyte, what about in a terabyte text collection? We can calculate and approximate. On top of that, we are trying to apply the linguistics pre-processing like stemming, stop word detection, normalization. They are also reducing by at least from 13% up to 15%, especially for English textual documents. At the end of the day, we are only indexing 25% of the whole content that are extracted from the original document collection, which can greatly minimizing the memory space requirement. And also, we have restricted number of words for searching, which can optimize the searching speed. One concept here you have to remember is, according to Heap's law, as the number of document collection increase, the number of words are increasing at a decreasing rate. That means, as the number of words increase, as the number of document collection increases, the terms are increasing logarithmically. If you calculate logarithm of 16 to the base 2, you will get how much? 4. If you take 16 as a word, logarithm of 16 words to the base 2 is giving us 4. But what about if you collect 1024? Logarithm of 1024 to the base 2 will give us how much? 10 only. So as the number of document collection increases, the number of distinct words that we are collecting from the document collections are increasing, logarithmically. That means increasing at a decreasing rate. That is the basic principle defined by Hipps law. By conducting statistically and by experimentally looking at how the words are increasing as the document collection increases. So that has a great advantage for when we are designing also an information retrieval system. So the major steps that we follow in index construction is, obviously, when we attempt to index, first of all, we have to collect the text documents from the author's world. After collecting those documents, they have to pass through index term selection step. For selecting the index terms, what are the steps that we have to apply? As we said earlier, to identify index terms, to identify query terms, especially when we are selecting non-content bearing terms. We have to go through tokenization step, which is always there, then stop for detection, stemming and the normalization, finally, weighting by applying term frequency, document frequency, collection frequency. Then after identifying a weighted index terms, a weighted index terms means for each index term, we know their term frequency, document frequency, collection frequency. That means what? We know for each index terms how many times that term appears in a given document, how many times that term is appearing across the document collection, how many times that term is totally occurring in the whole collection. So term frequency will tell us the frequency of occurrence of the term in each document. Document frequency is telling us how many documents are containing that term. Collection frequency is telling us the total frequency of occurrence of that term across the document collection. So by collecting this information for each index terms that are normalized, stemmed, and obviously they are non-content bearing words because stop word is applied. Now the next step is using index file, indexing structure, organizing them, organizing the index terms. We have the information about terms. We have document collections through their document ID, identifier, and we have term frequencies. Then using this, we have to organize our terms. When we are looking at the basic indexing process, given a document with some write-up internally, we have to first of all tokenize and identify the token words, token terms, or a bag of words. Then we have to convert into index terms. To convert them into index terms, we have to apply the linguistic pre-processing or the text pre-processing. Stop or detector should be applied, normalizer, and the stemmer. After applying stop or detection, normalization, stemming, then by organizing index terms along with their frequencies, depending on the index files that we use. Some index files are not using term weight, others are using term weight. Especially the inverted file is preferred because it is also helps us to organize the term weights that are telling us the frequency of occurrence of each term in a given document across the document collection. Again, why we are preferring inverted file is because inverted file is trying to organize documents based on the words that are containing, because a given word is not only available in a given document. There are many documents that are containing one word. When we are using words for indexing, we are bringing different documents that are containing that word into one entry. As a result, identifying through the query terms a given word available in the index means identifying all the documents that are containing that term. And you see each of the indexing structures or index files. The basic thing is when we are building the index file, if you are using a good index file, it is trying to organize all the document collection using the index term. So given a word world, then if you are reaching to that word, you will identify all the documents that are containing that word. Just you are expected only to search for that word. Such kind of indexing structures are required nowadays, since our documents are increasing at alarming rate. And that's why we are preferring also inverted file. Index files are like a lookup files because they are helping us, they are guiding us which documents are containing the query terms. We can easily identify documents by looking at whether a given document is containing the query terms or not. For that, whatever index file that we are selecting, it should also facilitate searching. Nowadays, there are many indexing structures available, like sequential file, which is the first indexing structure introduced by scholars for organizing index terms and creating the index file. Later on, inverter file, signature file, suffix array, many other algorithms are designed. So we'll try to see, based on their advantage, the sequential file, inverter file, and signature file. For selecting any of the index file, that means the indexing structure, what are the criteria we have to use? Obviously, we have to see to what extent by using that index structure for creating the index file, speed up searching. We need the searching should be as fast as possible in identifying relevant documents. For that purpose, we need a good indexing file that runs faster during indexing, during searching also, even during updating. Nowadays, document collections are alarmingly growing. Per day, a number of documents are published here and there. So updation is frequently required. And the updation should be done as fast as possible. When we are updating, basically, there are two major types of updating. Like in learning, we have, I don't know whether you saw it or not, in data mining or machine learning, there are relearning and incremental learning mechanisms. Because our data are growing faster, how can we make the machine learning algorithms or the data mining algorithms learn faster whenever the data is changing? That means how we can make it modify the model created. Either we have to go for relearning or incremental learning. Incremental learning is very fast as compared to relearning, because relearning requires taking the existing data with the already existing data, means the new data with the already learned data, by removing the already created model, make the machine learning algorithms or data mining algorithm create again a new model which takes into account the new data. So you are running again using the new data and the existing data for creating a new model in the case of relearning. The issue at that point is why we are making the system learn again whatever it learned previously. The existing data already, it knows them, and it already identified patterns and created a model. What we are expected is to update the model. To update the model as per the new data, we have to make the algorithm learns only the new data, extract patterns, and then update the model. Without affecting the model, it has to add the new patterns into the model. In our case also, when we are creating an index file, we have to make sure that that index file can be easily updated without taking that much time. Because again, here we have two options. Re-indexing is possible, incremental indexing is also possible. But we are preferring incremental indexing. Re-indexing means take the existing document collection, the already indexed one, take also the new document collection, merge them, create a new index file by ignoring the previous index file. That is re-indexing. But if we already index them, the issue is if we are already indexed the existing document, why we are re-indexing them? We can take the index file of the existing documents and then take the new documents, and from the new document extract index terms, and those index terms include them within the already existing index file. To do these things, the indexing structure should allow us. Inverted file can be incrementally done as compared to like sequential file. The other criteria is the space requirement. The index file should take as much as possible minimal space, or it has to optimally use the available space. And also access type. What kind of access type supported by indexing structure? Is that possible to access multiple index terms at the same time, or only one term at a time? Each records that are describing one term, or multiple records that are describing multiple terms? We are preferring if it's possible to access multiple rows, multiple records, or multiple index terms at the same time. Obviously, the first indexing structure design is a sequential file, which is simple. To organize document collection based on the index terms. The name itself is sequential. We are taking index terms without any term weighting calculation, or the index terms are organized. Maybe you will get the same index term appearing multiple times. If that index term is available multiple times in the same document or in multiple documents. As a result of which, maybe our index file becomes very huge, even if it is very simple to construct. But it takes much space, since we are organizing all the terms that are identified from our document collection. We can say all the index terms identified from the collection. Even if there are multiple terms identified from one document, or the same term identified from the same document multiple times, maybe the same word appears n times in a given document, m times across the document. So that term is appearing n plus m times within the sequential file. If you see in the example, downtown is appearing multiple times, 2 times. Perry Ridge is appearing 3 times. Why they are appearing multiple times? Because there is no term weighting used. If we use term frequency, we can control the multiple times term occurrence in a given document. If you are using document frequency, we can control the multiple times occurrence of a term across the document collection. Let's take an example. We have assumed 2 documents. The first one is containing this text. The second one is containing this text. As we said, the first step is tokenization, stop detection, normalization, and stemming. Normalization will give us each terms that are available in the 2 documents. All the terms are identified. When we are applying stop word, I, did, was, the, me, so are removed. If we apply normalization, the capital letters are converted into small letter using lowering script to lower in Python. Then if you apply stemming, like killed is conflated